Okay, so we're about to get started here. If anyone wants to do a last minute AV check, now you have a minute and then we're gonna get started here. Okay, so welcome everyone. This is the Thing to Thing research group, what we call a pre-IETF summary meeting. So at Thing to Thing research group, we organize these summary meetings to reach out to the broader IoT community around on the topics that we do, but then the actual work happens in a more usually more focused meetings, workshops, and such. But these events are good to get an overview on the activities that has been happening between the summary meetings. My name is Ari Keränen, and my co-chair at Thinking Research Group is Karsten Borman. As usual, since we are in an IRTF meeting, the note will apply. The short version is that if technology works as expected, you are being recorded. You should also be nice to each other, and there are IPR guidelines that do apply here. For more details, you can have a closer look at these slides. Essentially, if you are aware of related IPR, you should be disclosing it. And when it comes to privacy and code of conduct, everything you do here is essentially public, and recordings will be made public. There's a policy on how personal information is handled, and also you agree to be respectful with each other. And there's a bunch of links for more details on all of these. And finally, a quick reminder about the goals of the IRTF. So this is a research group. So even though we do close collaboration with the IETF, where related standards are done, in this group we do mostly research and we do discussions and really promote development of collaboration and teamwork, exploring the issues that are related to the technologies that are often then standardized on the IETF side. A quick administrative for notes, we do have the IETF note-taking tool. There's a link in the meeting materials and also here on the slides. The chairs will be taking notes in the tool, but we also welcome everyone here in the meeting to join and take the notes together. Same thing goes with Jabber. We will be looking at the chat and relaying if you have comments you want to be relayed to the meeting, but also everyone else feel free to chime in. And if you haven't already subscribed to our mailing list, thinkingrh@irtf.org, please do that at the following link so you will be updated on all the activities. And we commonly have GitHub repositories about all the meetings that we organize. And for this particular meeting, you will find all the information and materials on the last link. Then going for the agenda for today, we are now in the chair's update slot. Quick update about the research group status and upcoming meetings and activities. After that, we have two longer slots for a research talks. We have first from Chen Gundogan about data-centric co-op transport, and then from Steve Hanna about a Matter, this new IoT smart home organization, and their security and privacy for security and privacy expert discussion. Follow that, we will be giving a brief update from the Wishy activity. And then we have two updates from SDOs that we work closely together, W3C Web of Things, and from 1DM and Iot Schema. Finally, if we don't go way over time, we do have a bit of flex time to be flexible on the timing we use for those previous topics, and then perhaps in the end, a few minutes of wrap up before we end the meeting. Any questions or comments on the agenda? Okay, so after this meeting, our plan is that we would be continuing our regular Wishy calls. We have had them sometimes roughly every month, sometimes a bit less frequent. We had one just yesterday, and we are now planning for the next one, perhaps before Thanksgiving, so towards the end of November. This time we are not planning to have a team-to-team research summary meeting at the IETF virtual meeting. However, there's a good chance we'll have some Wishy-related activities at the hackathon on the week before IETF, so stay tuned about that. We also often have online meetings with other organizations, for example, OCF, OMA SpecWorks, W3C, Web of Things, and there is one small meeting already planned for this Thursday together with the Web of Things group. Also, we've been long discussing that we should do more co-location with academic conferences, and this time we actually do have. We have the DICE snack workshop on December 7th. You can find more information on the link on the slide. But overall, we will be very keen on doing more of this co-locating with academic conferences. So if you are organizing such or you know a conference which would be a good fit for Thinking RG co-location, please let us know and we're very happy to talk with you. And then also, hopefully next year, we'll be able to go also back to more actual face-to-face meetings. So whenever the corona situation allows, we hope to have also physical meetings upcoming in 2022. But that, of course, still remains to be seen when we actually get to that. Briefly about the research group document status. The RESTful design for IoT document was updated recently. We did improve the terminology in particular, and also added more details on the affordances that were not discussed in much detail on that version yet. The authors do believe that there could be still many things added there, but on the other hand, we have to draw the limit somewhere, how much things we add there and when do we actually publish this. So we believe this is probably time to go towards publication of this document. And the next steps here are for the have a chair's review and then go towards last call. But if you haven't looked at the document recently, please go ahead, have a look, send your comments to the authors and to the list, and let's get that document published. Likewise for the Edge and IoT, there's some more details coming that on the following slide, but also for that, the expected time frame is that we would be getting a publication requested also during this year. And then we have the document secure bootstrapping for IoT, also coming more details on the following slides. There we expect that the publication request perhaps would be happening sometime next year. Also, we have had in the Wishy a discussion about this IoT information model standard description that is in the plans of turning into Thing-to-Thing research group document. And in addition, in the Wishy work, we have had a large set of discussions and some of the document in the Wishy wiki. We do have a plan on turning some of those Wishy notes into research group documents also. If you're interested in participating in any of this work, just approach the chairs and we'll be more than happy to connect you with the right people. Then briefly about the two drafts. So we asked the authors to give us a few bullets on the current status. And this is the one for the IoT Edge challenges and functions. So a new revision was published in August. Then that revision now reflects the feedback from the 1M2M community members, in particular new use cases in section 2.4, and also more details on section 4 about this 1M2M service layer and related to the text to relate to relevant functions. Also, there was a good review last week from Roberto Morabito that the authors are now planning to address and post a new version. But that seems to be the only open comments at the moment. So from chair's point of view, after those comments are addressed, we think we would be ready to move towards last call with this document and get it published. So of course, now would be a good time to hear if anyone has any comments on this, or do you believe that we are ready to go forward with this document?
I do want to say I did not get around to submitting a review, but I did read it twice. I just didn't manage to get the detailed notes up. I had not read the latest version, number 3, but I was most of my comments were small matters in the previous version, so I think that I'm okay with version 3 being published.
Okay, great. Thank you, Michael. And of course, if you have if there's some still comments you haven't had a chance to share, go ahead and share with the authors that they can still address. That would be great
Yeah,
to be able to.
I think in general the problem was I had no clear way to how to like send in an annotated file, which I guess I should have just scanned it and sent it in. But if there was a mechanism like let me annotate a file with comments in a Word document that could be annotated or something, that would have been helpful. But anyways.
Well, the IETF way is doing pull request. I'm sure this is available here as well, but whatever is most appropriate for you, please use.
Well, yeah, I'm just making excuses. I just kept getting distracted and never did finish the job. So sorry about that.
Okay, thank you, Michael. And yeah, give it a try and do reach out to us if you think you need some help with that. But yes, would be great to be able to move forward with this. Okay, then on the other draft that used to be known as secure bootstrapping, and nowadays known as terminology and processes for initial security setup for IoT devices. There was a major new revision submitted just some short time ago. There's a new title. In particular, the secure bootstrapping was renamed into initial security setup. There is a description on how you do the initial security setup in Bluetooth mesh, and also additional terminology by each standard protocol that was identified and listed. And also in the next version, the idea is to be identify initial assumptions and knowledge on the device after setup. The authors are now looking for feedback. In particular, if your favorite protocol or standard is missing, please do reach out to the authors. You can send comments to the mailing list or directly to the authors. And we would be hoping to be able to move also this forward and hopefully get it published sometime early next year. Any comments or questions here? Okay, go ahead, Elliot.
Hi, guys. Everybody, good morning, good afternoon, good evening. Just a question about this draft. I haven't looked at the revision update yet. Is this the grand sum total of the changes that we're talking about, or is there more? I mean, if it was a major revision, maybe the authors might want to say a few more words.
Sure. Am I audible? Can you hear me?
Yep.
Okay. Thanks, Elliot, for the question. So basically what we had agreed over the last couple of meetings was that maybe calling the draft bootstrapping is not the best idea because some protocols and standards use onboarding and obviously some others use provisioning. So thanks to Karsten, he suggested the idea of using the term initial security setup. So the abstract and basically the introduction now has removed the reference to bootstrapping and now uses instead the phrase of initial security setup. And the other suggestion from Karsten was that instead of trying to categorize these protocols for setting up devices into managed and peer-to-peer and ad hoc, it might make sense to instead identify like who are the players involved. Is it the manufacturer, user, owner? Are there servers involved? And what kind of terminology does each of the protocol use, and what kind of information is imparted to the devices once this process is finished. So some of them might provision like entire access control lists, while others may just provision a single key, which you can then use against the authorization server. So what we have done in this update is basically restructure, so get rid of the old categorization of managed and peer-to-peer and ad hoc. Instead, now we have like we don't try to categorize. Instead, we just have a list of common protocols and then try to identify the terms they use, the players that are involved, and this is work in progress. So the remaining part is basically like what are the initial assumptions. So if the device is supposed to be shipped with a vendor certificate, then that's an initial assumption, and these we still need to fill in. It takes a little while to go through each standard and kind of figure out the details, but I think the structure is more or less ready. It's more like going through each of the standard and then filling up the missing information.
So that was a pretty good and comprehensive answer to my question.
Okay, thank you, Mohit. Any more questions or comments on any of the previous topics before we move on? Okay, so then we had the research talk about the data-centric co-op transport. Cenk, would you like to go ahead?
Yeah, thanks. Let me share my slides. So I'm sending a sharing request.
And now it should be working.
Yep.
Good.
All right. So first of all, thanks Ari and Carsten for providing the slot. In this presentation, I want to share like the insights that we gained by looking at a data-centric co-op deployment option. My name is Cenk Gündoğan, and I'm a PhD student at the HW Hamburg. So first, when I say data-centric, let's have a look what that means. And by data-centric, we first look at a paradigm that's called information-centric networking. It's an alternative paradigm, and it's basically deployed on the networking layer and replaces, as you can see in the stack, replaces the host-centric IP networking. It is highly specialized on content delivery by providing very loose coupling of data and the data per users. There are a couple of architectures that implement the ICN paradigm, and the most well-known are named data networking, which is abbreviated NDN, and content-centric networking, CCNX. The key features of these protocols are that they have a name-based forwarding, they have stateful forwarding, which operates hopwise. They have caching that's also hopwise, and they use security on an object level. When we look at the technical aspects of CCNX and NDN, then we can see that we have a request-response paradigm. So we have an interest message and a data message. These are the primitives of the protocols on the network layer. They have a flow balance and the request state. They build request state on each hop. So every time a node forwards an interest message, there's a state built on that node to eventually build a reverse path for the response message. We have the caches. So when an interest hits a cache, then the data is returned along these the states. And we have an hopwise retransmission mechanism. So when we lose a message, a data message, then the retransmission happens. So we send another interest, and the good thing now we have the caches. So the interest actually does not need to traverse the whole path, but any cache in the middle can respond with the data. And of course, because it's a very good combination with the caches, NDN and CCNX are using security on the object level. So the data message is either protected by an HMAC or using digital signatures. So the current research indicates that they are like these information-centric properties, the stateful forwarding, the caching, and the object security. They are actually promising and kind of good candidates for IoT deployments. The stateful forwarding and caching, they shorten the request paths, as I said before. So they reduce the link traversals and the number of transmissions and packets on the link. And the security enables an end-to-end security that even goes beyond untrusted gateways. And also, but we will see this later, they also allow a multi-party communication, which is not so easily achieved with transport security. And while we are looking into these kind of ICN networks in the IoT, we figured that actually the CoAP standard already gives a lot of the features that we sorted out here. If you look, for example, at CoAP proxy, which is in the main RFC of CoAP, then they already provide a caching mechanism. They also have stateful forwarding. And now that we have the OSCORE RFC, they provide, of course, the object security. And in combination, we try to build something that we call the data-centric co-op deployment option. And this is the next thing on the agenda. After that, I will show you how we made this possible to have a multi-party communication using this data-centric co-op deployment. It wasn't so easily achieved, but you will see. And then I will show a brief use case by how we send the firmware updates using this deployment option. So again, very brief. The typical co-op deployment looks like this. We have a client, we have a server, and in the middle we have IP forwarders. Anything is happening end-to-end, and also the retransmissions are happening end-to-end. We have the request and we have the response. And with the new deployment option, the data center deployment option, we have, again, a client and a server. But in the middle, we have now co-op proxies. So we are building a path of proxies. And this gives us the stateful forwarding that we saw before in NDN and CCNX. Everything is happening hopwise now. We have hopwise caching, and even the retransmissions are performed hopwise. We have a forwarding that is now happening on names. So again, it's very similar to NDN. And this is something that we implemented and deployed in the scope of this paper here, which we submitted last year to the ICN conference. If you look at this in more detail, then we see the following. So there are three data structures. They are basically the same data structures that also NDN and CCNX use. Let's first start with the cache, because that's already present in the co-op RC. Pretty good, well-defined. The request table is something, or let's say that this way. I think the proxy operation itself is in the RFC of co-op is a little bit unspecified regarding how the proxy is handling all the requests that it receives and how they are stored and what information we need to store and stuff like this. So we implemented a request table, or basically did the same things that NDN is doing. We used the cache key because it's already well defined in the co-op RFC as an identifier to identify distinct requests. And we have a proxy level FIP implementation. It's basically just information to store the next hop for a specific name or URL. So now if you look at this example, we have the client. It's requesting, you can see the URL on top. It's using, so in this case, we are using forward proxies. So we are using the forward proxy URI. We are requesting from a specific node the sensor resource. Since everything is hopwise, we can use link local IPv6 addresses. So the initial request goes one hop further. And we are putting this information into the request table of that node. The next node sends an empty acknowledgement to fulfill the confirmable gets, and then stores that information where the request comes from into the request table and forwards that again to the next node. And once we are at the end node, let's say, so the node before the actual server, or maybe here's a gateway and then we have the internet, this node is resolving the forward proxy URI and puts it into a URI path and can use the global IP address to request like the actual content. So when the server receives a typical request that we would also get from a normal co-op deployment, this node sends back a response, and the response then traverses back the reverse path that was built in the request tables. So we know where the request came from, and we can send back the data there. We consume the request state, and this is done until it's received at the origin of the request. So this is the whole chain, how it looks like. We of course have there's OSCORE to provide security. So what OSCORE is doing is that it wraps co-op and co-op. It rewrites the method into a post method. There's like this small trade-off we can have. I mean, the proxy URI itself is outside the OSCORE context, but you can have this trade-off of whether we should put everything, like the whole host part, into the proxy URI, or also the path itself. So this is basically a trade-off between, do we want a fine-grained forwarding on the proxy level FIP, or do we want more privacy and also only have the global IP address part exposed? So here's a very short packet dissection. The only thing I want to show you actually here is in the middle part, you see the co-op data center deployment. You see the en route forwarders and the packets for GET and the response packages. And then the last hop. The last hop is the same as typical co-op deployment, because it resolves the proxy URI. But in the en route messages, you can see that the 6LoWPAN part actually is reduced. And this is because we are using the hopwise forwarding, and in this case, the IPv6, the link local IPv6 addresses, which means that 6LoWPAN can do a much better compression instead of having global IP addresses. Here's another insight that we got in this paper. It's a little bit unrelated, but we were testing the setup against a typical DTLS setup. And of course, OSCORE is operating next to co-op, so that retransmissions, which happen actually, or can happen frequently in these setups, that the retransmissions don't need to re-invoke the whole security measurements again. But for DTLS, because of this layered approach, every retransmission has to retraverse the DTLS record, which again introduces overhead, computational overhead. So we have this picture now of how the data-centric co-op deployment works. And then we thought, okay, we can do multi-party communications because NDN supports that intrinsically. So this means we can have request messages from multiple sources. At some one point, it's aggregated, and then we only have one request that goes out. And when the responses come back, they fan out. At the same time, we can have a request fan out mechanism. So the request is received by a forwarder, and then they fan out, and we have response deduplication mechanisms. So this is what NDN gives you. But then we figured out, okay, if we use the typical OSCORE and integrate this into this whole setup, then we have a problem, because OSCORE actually has a very strict message binding. So a single response can only match a single request, which denies everything that multi-party communication needs. And then for the caching, of course, because it's encrypted with a specific key, and for an endpoint, it's not very feasible or possible to get the data out of the cache for another node. And this is what we looked into this paper, this year's LCN. This is where we implemented basically let's say, more or less a solution for that. We were looking into the draft from Christian. I think he's also here in the call. I think also Marco Tiloka is also an author of this draft. So basically, all the nodes of a specific group assume a virtual client, the role of a virtual client, and they have the same keying material. And every request that is generated by using this virtual client role looks the same. So now we can have the actual cache utilization that we want. And also we can do the request aggregations because the requests now look the same. And this looks the following. So in the picture below, we can see the example where a request comes in on the forwarding node. If there's a cache hit, then that's okay. The response is returned. But if there's no cache hit, then we look at the request table. Okay, there is no request there, so the request is forwarded to somewhere. If there are now multiple requesters and multiple requests coming in, they match. So the cache key, which is what we use for identifying the requests, if they match, then they aggregate on the request table, and they stop there, so they are not forwarded again to the server. So now if the response comes back, then first it goes into the cache, and the response is fanned out to all the requesters, of course, using the same tokens that we have to record for each request. A very small evaluation that we did on the IoT Lab testbed using the M3 nodes, which is they're deploying an ARM Cortex M3 architecture, and they have 15.4 radio capability. We used the right operating system for doing the measurements. We have the topology on the right, so we have 9 clients, one server, and some forwarders in the middle. And the scenario was that each client requests an instruction, so it's data that is the same for all of them. So this could be like a light fixture, and they want to have the instruction for a specific time. So what we see is on the x-axis, you can see the content retrieval time, so how long it takes until the instruction is received by a client. On the y-axis, you see the CDF, the distribution function, and then we can see the protocols for OSCORE and OSCORE proxy. OSCORE is only the end-to-end co-op deployment. OSCORE proxy is the end. It is a hopwise co-op deployment, but it's not utilizing the cacheable OSCORE draft. And then we have NDN, and then we have the OSCORE proxy with the cacheable OSCORE draft. So we can see that for the first 2 protocols, the content retrieval times, I mean, we can see retransmissions happening. This is what's happening every 2 seconds. We have the steps. These are the retransmissions. But also we see that not all retrievals are actually received. So we don't go up to 100%, but stay at almost 30% of content that is actually received. If you look at the NDN and the cacheable OSCORE, then we can see that they go up until almost 100% of instructions that are received. Also, if you look at the sub-second range, we can see that the latency decreases a lot, and this is because that on the long paths that we had in topology, there is already the content available, the instructions from previous client requests, and so we don't need to traverse the whole path. So now we look into this use case, the firmware update. I think we all agree that firmware updates are necessary in the IoT, but there are a few challenges. The problem is that, like the propagation of the firmware itself, it is resource consuming. The IoT firmware is actually 1 to 2 orders of magnitude larger than typical sensor values. And then we thought, okay, let's apply the co-op deployment, or in this case, actually we used NDN because it was for the ICN conference. But now that we saw that we can basically replace this NDN deployment with the co-op deployment, and yeah, I mean, it's on our agenda to actually implement this also with the co-op deployment, but everything should hold for the co-op case. So in this paper, we followed the suit philosophy. So we have a manifest file to request meta information on a specific firmware. And once we receive information, we can request multiple the firmware itself, which is chunked because it's typically too big for the MTU of those link layers. With the co-op case, we would probably use blockwise transfer to do this with the core deployment. So once everything is received, we verify the image and boot in your firmware. Since we have the stateful forwarding, we can actually decide how the retrievals are happening. So we can have the typical, the concurrent retrievals is when each node somehow discovers there's a new version, and now they autonomously request all the firmwares, and this can happen simultaneously. So we can have simultaneous updates happening on the same path from multiple nodes. Or we can have this cascading retrievals where actually an upstream node is blocking downstream requests until that specific node is not finished with its own firmware update. So we will see how these will perform. So we have a new experiment here with this topology. Again, on the testbed, we use RIDE 30 devices, and the use case is that each device is requesting a firmware. And I marked this specific path here in red, and this is what we will look at in the next plots, because it's the longest, or one of the longest paths, and will probably have the highest stress. So all devices are requesting a firmware that's 120 kilobyte big. It's chunked with 4,000 chunks. We have on the x-axis the experiment duration. You can see it goes into the minutes range, and on the y-axis we have the chunk retrieval rate. So how long does it take? How many chunks can I receive per second? We have this for the concurrent and for the cascading retrieval strategies, and we have the nodes N1 to N7, and 7 is the node that's the farthest away. So we can see for the concurrent case that the retrievals, first the download process takes a long time. So if you look at the N7 node, we can see that the chunk retrieval average is actually 2, so we are only receiving 2 chunks per second. And it takes almost 30 minutes for that node to complete. So that's the worst case, because it's also the farthest away. If you look at the cascading strategy, so when the upstream nodes actually block the requests from downstream nodes until they finish their own download, we can see that we have a much more relaxed scenario. So every node actually finishes the download process in around 4 to 5 minutes until everyone is finished. So that's the next and last plot. We now wanted to see, okay, how will this perform if we don't have the caches? So basically, how will this look like for an end-to-end deployment, for example, by using CoreApp? So we have the same, or a firmware image of 128 kilobyte, and we have, again, the concurrent and cascading strategies. We have the update completion time in minutes on the x-axis, and the CDF on the y-axis. And now we have these 2 scenarios. One, in the first scenario, we are deploying a common binary, so binary that's used by all the same nodes, by all the nodes. So we can actually leverage the caching. This is what we saw before. The nodes finish, or the latest download finishes at almost 32 minutes. And now if you deploy the individual binary, so each node is having a single binary, so we can cache, but we can't utilize the caches, then we can see that this explodes until the more than two hours. Okay, so we come to the takeaways now, and we saw that, like, the information-centric content retrievals, they are more efficient because of the caching and the stateful forwarding. We also have the object security, and it allows us to do a multi-party communication, which is not so easy to do with transport security. And also we have new perspectives for IoT deployments using this data-centric CoreApp deployment. Now, you probably wondered how the forwarding information on the proxy level is maintained and handled. There's no solution yet. We did everything with static routes, but we plan to look into how to actually discover these hopwise proxies and to build some form of dynamic path to the content. And also in the proxy URI, we were using global IP addresses, but this could also be just any identifier that is mapped on the forwarding information base to some link local address. So it doesn't need to be actually an IP address, but this is also in the future. So this concludes the talk, and I'm happy to take any questions from here. And thanks for listening.
Thank you, Cenk. Very, very interesting presentation and topic. So anyone, if you have questions, feel free to join the queue. We'll be taking questions from the mic queue. But while waiting for people to join, I had one question on this, that it seems that you're reusing a lot of existing co-op functionality. So I was wondering, like, what is the impact on implementation? So if I do have for example, a co-op proxy that already supports plain co-op and OSCORE, how much extra do I need to do to actually support also the kind of technology that you were showing here?
So I tried to explain actually here that by reading the co-op RFC, I wasn't really sure how the proxy is handling all the states. So the state management is, I think, maybe I'm wrong, but I think a little bit underspecified in the RFC itself. So I'm not sure if this is like too custom or not, but I could imagine that a proxy would do it like this. And this would be something that would need to be implemented extra, I guess. But this is not, I mean, that's not so much more than having all the other parts. So I guess it's pretty easy to converge to the data-centric co-op deployment from just having the standard blocks.
Okay, very good. Thanks. And then on the forward part, I was wondering, have you been, I mean, in the ICNRG, they have been looking at the same topic also quite a bit. I guess you have already discussing with that group if you have found common ways that you could actually achieve that.
But the forwarding, you mean?
Finding the forward.
Excuse me?
I mean, finding the forward path, like
the path, yeah. So basically the future work part. Yeah, I mean, I think it should be possible to have to take any NDN routing protocol and use it on top of this to find the names. But I also think it could be possible to actually have to take an IP protocol. I didn't look into it, but maybe it's possible to, for example, take Ripple and adjust Ripple to, I don't know, to somehow have the name information and distribute the name informations in a DODAC. But this is something that needs more elaboration and to look into it. Maybe it's even possible to use resource directories to learn which resources are out there, and maybe then build a path towards that. But I don't know yet and can't tell more, I think, on that topic. But it's definitely, it's an open issue and something that needs to be addressed if this is of interest. That's, I agree with that.
Great, thanks. Looking forward to hear more.
Yeah,
Carsten,
thank you.
Go ahead.
Yeah, my question is designed to be the last one. And I think from the timing, it probably is. So there is a large body of ICN research out there, and one wonders what are the next pieces of that research that you actually will start to borrow. What are the most useful elements that we could use for this kind of data-centric co-op-based environment?
Yeah, that's a very good question. So by having this co-op deployment, data center co-op deployment, of course, we open the door for all the ICN research that's done. And they have a lot of research on caching strategies, cache placement, replacement. And I guess should be fairly easy to adapt a lot of these things into this kind of deployment. So, I mean, as we all know, we have almost no memory on these devices. So we need some form of cache placement strategies. In this case, I think I used the least recently used, but there are much better strategies to take from these from the ICN research. Besides that, there are a few like publish subscribe schemes from the ICN world that might also be beneficial to have even more like loose coupling. But I'm not so sure about yet how this might look like in these deployments. But I think the caching is something that we can definitely use, and it's easy to get.
Thank you. So we are looking forward for a lot of more research on that from you and from other people.
Yep. Thank you also.
Very good. Thank you, Cenk. And because we're now exactly on the right time on the agenda for our next talk. So welcome, Steve Hanna. Would you like to share from your screen?
Yes, I would. Can you hear my audio okay?
Yes, we can hear you.
Okay, great. I'm going to share my screen now. You should see
And
the
now we can
slides.
see. Yes, thank you.
Okay, very good. The full screen view, I presume. Yes, I see it. So I'm thankful for your invitation to come here and to talk a little bit about Matter, the set of open standards for smart home security, or for smart home, rather, I should say. Security is my special interest, so that's what I'll be talking about, security and privacy topics. There are many other aspects to Matter, as you'll see. I do include some introduction and overview information about Matter in the presentation. All of this comes from the Connectivity Standards Alliance, which used to be called the Zigbee Alliance. The Matter, by the way, used to be called Project CHIP, or Connected Home over IP. And it is an industry standards group. And as such, the specifications are not yet widely available, only to members. They will be available to everyone once they're complete in the 1.0 version. So this is an opportunity to get a sneak peek at how the security and privacy works there. And I think there's some interesting innovations that you'll enjoy hearing about. I have to apologize, though, that the information here is necessarily incomplete because, well, for one thing, the standards aren't quite finished in even the 1.0 version. And I'm not allowed to present every detail of the draft standards. I'll apologize as well that my presentation may be suboptimal, as I've been diagnosed recently with COVID. And although I'm happy to say that my vaccines seem to be doing their job, I may not be up to quite my usual standard. And thanks as well to the IRTF community for your assistance, in particular, Ran Canetti, former chair of the Multicast Security Research Group, who provided essential assistance to Matter simply in giving us an overview of multicast security topics some 15 months ago. All right, let's get into it. We have only 30 minutes for this, and I'd like to leave some time for questions. So I'm going to cover an introduction to the Matter standards, a presentation of the security and privacy principles, description of our threat model, which is always a necessary prerequisite when talking about how one is addressing security and privacy, and finally, the security and privacy architecture. So an introduction to Matter, perhaps you've heard of it, it's been in the press, and you might want to know a little more. Well, Matter is intended to be of widespread utility within smart home and perhaps beyond. And that's why our marketing team has chosen such a bold name for it. Matter, it's of course the one thing that all things in the world have in common. They'll have some matter, formed of matter. And so this is intended to convey the foundational nature of the standard and what we hope will be the eventual ubiquity. The Matter logo, which appears in the upper left corner of the slide, is something that we intend to indicate to consumers that the marked devices will work together compatibly and seamlessly as they look today for logos like Wi-Fi or Bluetooth, but spanning multiple network media. And one of our essential goals is to simplify the process of developing and using smart home and IoT products, so that consumers don't have to worry about how it's going to work or whether it's going to work. There are 4 pillars of Matter, the Matter effort: simplicity, interoperability, reliability, and security. And I won't go into these in any detail, but I think the most important thing from my perspective is security made the list. Yes, we're last, but but we are on the list. It's recognized widely by the Matter participants that security is absolutely essential for Matter and for IoT. You can't add it later. Now, how does Matter work? Well, it's an application layer stack. It rides on top of TCP or UDP. Requires IPv6 and works over any IPv6 compatible network. That being said, it does include some native support for Wi-Fi, Thread, and BLE, and other underlying media may be added later. In that, as you'll see later, when you bring a Matter device into your home, we can automatically provision Wi-Fi credentials into it. So that's not a separate step, but can be handled as a seamless and single process. It's designed, as I said, to be secure and to use standard commercial algorithms for cryptographic algorithms and protocols for cryptographic protocols. We use an open source development approach, and the source code is already available. I'll include the link in a few slides. The source code is based on technologies and source code already used by the members. So a lot of contributions from the members there. We didn't have to start from scratch. And it's designed, because it's IP based, to not have to go through a bridge necessarily, a protocol translation module, to get from your device, however small that device might be, to your mobile and eventually all the way up to the cloud. So we can have end-to-end security. Matter as an application layer protocol doesn't just include, say, security protocols like TLS would, but also has a data model. And this means that we have a set of nouns and verbs specific to certain device types, such as, say, a light bulb, which would have on and off, or adjustments to the intensity, or perhaps the color of the light bulb, and similar other device types. Zigbee already had a set of a common data model, and this is being extended for Matter. It's designed to be a low overhead or relatively low overhead implementation. When you're adding IPv6, there is a certain element of overhead, and adding security on top of that as well is a bit of a burden, but still we're aiming to keep the burden as low as possible, aiming for less than 128K of RAM and less than a megabyte of flash or non-volatile memory. I know, having worked with IRTF and the deep thing-to-thing research group in the past, these may seem like large numbers to you, but for the world of IoT, they are, shall we say, medium, at least in smart homes. And they allow us to achieve our goals. One of our goals is ease of use, and I do want to emphasize that. The whole system has been designed to be easy to set up, easy for consumers to understand, easy for developers to employ in their products, and so on and so forth. So we'll talk more about the setup experience in the next slides and how that relates to security. But just to say that this has been a barrier in the past. Consumers will go out and buy an IoT device, bring it home, and they can't figure out how to make it work, or at least how to make it work with the devices they want it to work with. In fact, it might not be compatible with those devices, but also the setup experience is different for each device, and depending on whether you're introducing it to your Apple iPhone, your Google Android phone, or other Google Nest devices, et cetera, et cetera. It's just confusing because there's so many ways that it can work. I'll talk more about the multi-admin feature in a few moments and go into some more detail, but essentially this is a new feature which is designed to ensure that your devices, such as a bulb, will be able to work with whatever administrative and control devices you might have. So you might have, say, an iPhone and use HomeKit, or you might have a Google Pixel device and use Google Nest, or whatever you may have. That's permitted and required to be permitted, that the device can hook up to whatever ecosystem you already have in place, so long as they both support Matter and it can simultaneously work with multiple ecosystems at the same time. So that's the multi-admin feature referenced here. All right, keeping it moving. Matter supports an initial set of device types. These are the ones listed on this slide. And other device types will be added later. This is an ongoing process. And we do expect that controllers will be not only in the form of switches and dials, but also, say, smart speakers, smart screens, even laptops and mobile phones and tablets. We'll all be able to control these devices and control devices from multiple vendors. Of course, multi-vendor interoperability is essential here. I mentioned it's an open source project, and here's the link you can go to find the open source and to look at it today. It's intended to be quite open and accessible. That's why we've made the code already available. It's a Apache 2.0 license and includes lots of examples. It's one of our reference platforms is the Raspberry Pi. So if you have a Raspberry Pi, and probably most of us do, you could download the code, build it, and run it on the Raspberry Pi today. Well, I think I've mentioned all the rest here. All right, timeline. The specs are already available to our CSA members, and of course we would welcome you to join if you wish. The members have been working on the SDK. We don't intend to release the spec until the SDK is ready to release as well, because, well, as IETF would say, we need to have proof in the form of running code that the specification is a good one and actually works. There's a big difference between theory and practice. At that time, in the first half of 2022, when the SDK and the spec are released, we should have some products already ready for certification, because they're already undergoing testing now. And when I say certification, well, that every Matter device, everything that has a logo on it, Matter logo on it, will be tested just like Wi-Fi devices are tested to make sure that they're interoperable. Doesn't mean you can't create your own prototypes at home, but they won't be supported with a consumer in a consumer environment. They would need to be certified. Security and privacy principles. So these are the principles on which our design rests. Comprehensive approach. We don't just think about the security of the device, but we think about the security of the network and of the cloud and of the privacy of all of those as well, including any gateways if there may be some present. We're designing it to be as strong as we can, using well-tested standard crypto algorithms and protocols. And ease of use, as I mentioned earlier, is a requirement. In fact, one could say we intend it to be a hallmark of Matter. So that ease of use drives design decisions in the protocols and the design and the standards. We're designing Matter systems to be resilient. We recognize that it will be impossible to prevent every infection, and we want to make sure that it's possible to detect compromise and to recover from it, and to be agile. Well, with quantum computing just over the horizon at a practical scale, it's essential that anybody who's designing a secure system today include support at the very least for post-quantum crypto to be added. But in addition, we recognize that there are always new developments, and especially in the field of security, new threats that come along, and the protocols, the standards, and the devices, even after already in the field, need to be designed to adapt to those new developments and threats. So we've designed them to do so. All right, hold on a second. I think I'm going to do a little coughing. That does sort of come with the territory. Thank goodness for the vaccines. So what is the threat model for Matter? Well, when we consider threats, we consider all different sorts of threats. Any attacker or actor who's trying to compromise the system in any way. And this wouldn't just be your typical cloak and dagger government attacker, or an attacker from overseas performing some remote attack. It might be, say, a former lover or spouse, someone who stayed in your home. Perhaps you gave them access as a guest, house guest, and now you wanted to revoke it. Well, we have to make sure that's easy and possible without their cooperation. It could be a supplier, say the landlord or the builder. It could be some other trusted party, such as a cleaning person that you gave temporary access to your home, and now you need to revoke it. Or somebody who snuck into your home and you don't want that to become a permanent cyber intrusion. Could even be a house guest who's only there for a dinner party, and you don't want them to be able to compromise your home. They may have varying levels of access and resources and skills. We recognize that. And of course, we have to consider supplier security as well. If the supplier of your devices should be hacked or compromised, have their development environment compromised, for example, how is that handled? Or your cloud provider. We also consider the life cycle of these devices. Smart home devices may have a long life cycle. You might gift them to your children, or sell them in a yard sale, throw them in the trash and have somebody pick them out of the trash and then try to use them to get the keys that could be used to infiltrate your home. So we consider those issues as well. And as far as targets, I've mentioned already a variety of different targets, but one that's important to consider is the humans in the loop. Humans are often the weakest link in the chain. We can design a perfect protocol, but if the humans can't understand how to use it, or if it's too hard, or they have to remember long passwords, that's just not going to work. And so we try to consider these human factors and how different humans might be tricked into doing things that they might later regret. All right. Oops. Gone a bit too far. Well, I think I've talked about these things already. So when we look at the threats, and we've categorized now something about 200 threats to the Matter system, we categorize them, we analyze them and categorize them in three ways: severity, likelihood, and impact. Where, let's start from the bottom. Impact: what would be the effect of a successful attack? What's the scope of it? Does it just let the attacker control one device, or your whole home network, or the whole fleet of devices of that type? I won't go into all the details here, but we do also consider how difficult the attack is and whether it requires physical access. From that, severity is derived, and we try to make sure that we identify as many and address as many of these countermeasures as possible, especially the high severity ones. Here's an example threat where a maliciously crafted message exploits a device vulnerability, causing a device compromise. It's high severity, and we address it by requiring all devices to support over-the-air firmware updates, either using our means or another means. Now we'll get into the architecture. So a device comes from the factory with certain set of credentials. These PKI credentials issue from a trusted root here, and there can be multiple trusted roots which are distributed through a distributed compliance ledger. In this case, it's a self-signed cert from Bulby, and the PKI descends to a leaf certificate unique to that device and identifying what vendor it's from and what product ID or product type it has. Those correspond to a private key, of course, unique to the device and stored on the device, and a certification declaration for this product type, as well as a verifier that will be used later. When we bring the device into the home, well, the process of bringing it in and commissioning it is easy from a user standpoint. They just scan it, scan the QR code, that is, that we saw on the last slide, and then it indicate, yes, I do want to commission this light bulb, and it's commissioned into the home. It gets a set of credentials for the network and some other things that we'll talk about in the next slide, and it's able to operate fully within the home as a secured and trusted device within that home. There we go. And now, what is installed on the device during commissioning? Well, it's the things in the right column here. A new set of credentials. If you're familiar with IEEE 802.1AR, this is similar to the LDEV ID or local device ID. Now you see the device has a set of credentials specific to this home or fabric. The fabric ID is a 64-bit number chosen by the commissioner or someone that it trusts, and a unique node ID, another 64-bit ID unique to this device within the home. And this chain goes back to a root CA, which could be located in the home or elsewhere. It depends on how the particular fabric is operated by that administrator. Each ecosystem will have its own decision for where the root CA is located. There's a private key, of course, corresponding to the operational cert, and an access control list that determines who can do what on that bulb, like turn it on or off, or change its color, or with a higher level of privilege, perhaps change its access control list. And I mentioned already the operational network credentials, such as Wi-Fi credentials that are used by the bulb to connect to the home. So there are a few ways in which Matter raises the bar over what we have today in smart home security. And well, it's not perhaps so hard to do considering how weak smart home security often is. Easy, secure, and flexible device commissioning, which I've walked through a moment ago. The validation of each device to make sure that this device is authentic and certified, that its device type has been tested. That's the device attestation cert that I talked about earlier in the certification declaration. Ability to check up-to-date info on revocation of those credentials, device attestation credentials, through the distributed compliance ledger. a strong device identity, the secondary identity that's used within the home to ensure that only your devices can communicate within your home. And that secondary identity is used in the unicast communications, much as it would be in TLS. In fact, our unicast security design is based on TLS and uses the same SIGA protocol as TLS 1.3. And secured group communications. This provides assurance that using a symmetric group key that the sender and receiver are both members of the group. It doesn't provide sender authentication, at least at this version, but it does provide assurance of group membership and the ability to quickly revoke group membership as needed. Talked already about the ability to have multiple administrators, even from different ecosystems simultaneously, and about access controls and secure software updates via standard mechanism, or if you wish, a proprietary one. An additional thing that's provided is remote attestation. This is optional, but if the device supports it, it can use a root of trust to provide remote attestation of software integrity based on measurements taken at boot or at runtime. And the Matter team remains committed to continuing to raise the bar for security and privacy, both through our open engagement with security researchers, through our vulnerability response process, making everything open to encourage people to analyze and find vulnerabilities, report them, and to improve them. And it's our intent to continue, as I mentioned earlier, to improve the protocols and the implementation to fix problems and to address them proactively. Here's a link for more information about Matter, buildwithmatter.com, and a link for more information about CSA. And I see I still have about 3 minutes left for questions.
Excellent. Thank you, Steve, for a very, very good and interesting presentation. And as before, if you have questions, please do join the mic queue. So since there's no one else yet, I was wondering, can you, Steve, talk a little bit more about the protocol stack that you have on top of UDP and TCP? What kind of technologies do you have there today?
Sure. So we have a secure channel protocol, and the secure channel protocol, as I mentioned, is based on a Sigma handshake. Now, there's also the ability to do group communications based on a symmetric key that's used to encrypt and authenticate all of the packets. I believe it's a AES CBC that's used there, AES 128 for that crypto. Are there additional questions that you have about it? I have the spec open.
I think thinking about like you know, at the IETF we've been working on co-op, and then there's a few other transfer protocols that are used by different ecosystems.
Right.
Kind of wondering what kind of protocols have you chosen to use there, or is it something completely different than what everyone else is using?
It's a different mechanism, yeah. We're not using CoAP.
Okay, thanks. And I guess we'll see more information that when the spec is released.
Absolutely. And perhaps even sooner, I should mention that we have a white paper coming out with more details on the security aspects later this fall. And I believe that there's also intended to be another one on the transport and communications aspects of Matter that will come out later in the calendar year, I believe. It may not be quite firm exactly when that white paper will be out, but we do expect to have that out well before the springtime. And then, of course, you'll be able to see the whole spec once that comes out. Yeah.
Very good. Thanks a lot.
And we welcome engagement with the research community, of course.
Okay, and I see we have Karsten and Michael in the queue. Karsten, do you want to go first?
So I have two things. One from the Jabber. Mold City thanks you for the excellent overview and wishes other SDOs didn't even half as good presentations as this. And he also has a question on slide 23. Is it correct that the private key for the ACME certificate is generated outside of the device and then provisioned on it?
Hold on a second. I'll go back to slide 23. Yeah. Okay. Well, I'll try to go back. There we go. No, the private key can be generated on the device. Yeah, for the OpCert, that's what he was asking about.
Okay.
In fact, it is in this case, it would always be generated on the device. It's for the device attestation cert because of manufacturing difficulties. Sometimes it's necessary to generate a device attestation cert private key off the device and in a controlled and secure manufacturing environment inject it. But during operation, it would always be generated on the device.
Okay. Well, thanks you for the answer. I also have a question. You discussed the whole aspect of ownership transfer and even the scavenging case, the heirloom case. One interesting question that often comes up is when you have IoT devices that actually become part of a home. There are some that are kind of your personal bubble, like your smartphone and your smart speaker and so on. So you would take those with you. But there are other IoT devices that are actually installed in the home. And one interesting ownership transfer is the involuntary ownership transfer, where the whole home changes its ownership in an involuntary way. Is this something you have considered?
It is, and I'll be honest there and say that I don't think we've completely solved that problem. We have a solution for the time being, which involves physical access to the device, and then resetting each device individually. But this is a painful process, and we'd like to have something better in the future. We're just not yet there yet. And we won't be for 1.0. I think, yeah, it's a hard problem. 1.0 is a 1.0. It doesn't have everything we'd ever like.
Thank you.
Michael, go ahead.
Eva, thanks for a very pretty set of slides. They are very nice and explanatory. You mentioned that you use Sigma I like TLS, but you're not using TLS. And you don't seem to have any algorithm agility. And so I'm hoping that your white paper that comes out on security, I hope will explain to the community how you intend to deal with issues like that. That would be very useful to understand what the plan is. And I guess that wasn't really a question so much as a request of you to make sure that's an important part of it. And as to Karsten's comment about the involuntary stuff, so I have a document about this and some of the problems, and I'd love some more communication about that. And there's actually some people at Columbia who have apparently been doing, I saw a talk from, I can't say his name, Henning there, professor. And they have some interesting solutions. It's just not clear that they will fit in the smallest devices. So I would encourage you to, there's a bunch of stuff happening in the academic community, it seems, on this topic. And maybe that would be a good place to engage across the whole industry.
Great. Thank you for that tip. I will absolutely look for those papers from Henning. And as for algorithm agility, yes, it's designed in. Sorry if I gave an impression otherwise, but we are planning for a PQC transition.
So there is one more question from the Jabber. I see that there are several security design considerations specifically for privacy. Are there any considerations beyond the secure IDs?
Oh, yes, there are. So, for example, I won't be able to list them all off the top of my head, but there is an additional privacy key which is used across the fabric to encrypt all identifiers. So even identifiers that are used for addressing are, such as the node IDs, are encrypted in a manner that other people on the same Wi-Fi network, for example, would not be able to necessarily would not be able to decrypt those unless they had the corresponding fabric key. As for other items on that list, as I said, I'm not a privacy expert, so I would refer you to the white paper that we'll be publishing shortly, which has a list of about a dozen. Any more questions? Okay. No? Okay.
Okay. Very good. Thank you once more for Steve for making it here, and it was a very interesting presentation. I'm looking forward to hear more on this topic. And yeah, please keep us posted when there is more information you can share. It would be very interesting to hear about it.
I'll come back after the spec is public and we can talk about it then.
Yeah, and we wish you a quick and full recovery.
Thank you. I'm going to leave now. Go take a nap. Bye-bye.
Very good. Thank you. Okay, so if we then continue on the agenda, we have next a quick update on the Wishy. Let me get the slide doesn't seem to show up.
Let me try that.
I see that a new slide deck has been shared, but it's okay.
So I go to slide 11.
Yes, please.
No, that's not the right one. Right one, 14 maybe?
14 maybe, yeah.
Sorry.
Indeed. Very good. Thanks, Karsten. So a quick update on this recent work on the IoT semantic hypermedia interoperability. So this is an ongoing activity we have in the thinking research group, looking at the semantic and hypermedia interoperability aspects. Since the previous summary meeting, we have had two Wishy calls. One was around on SDF, so this semantic definition format that we are now working at the IETF-ASDF working group. But we had a discussion on some of the topics that go beyond the current scope of the SDF language, and in particular, how we could be looking at different relationships and instance information. So when in SDF, you can describe the affordances of IoT devices and more structure that they have using the SDF definitions. The idea here is that you could also describe potentially more complex relationship information between the definitions. So not just simple hierarchical information, but also, for example, that this kind of a light switch is connected to that kind of a light bulb, and they have this kind of a turning on relationship between them. And also another aspect that we have discussed in the wishing meetings is this instance information. So whereas SDF, you normally only define class level information. So for example, this is what a light bulb looks like. There are a lot of cases when you need to be talking about instances of those classes. And we've been discussing what would be the right mechanism for talking about that, whether it's an SDF extension or something else. Then another topic, a bigger topic that we had in the wishing meeting is this follow-up on the Azure Digital Twins definition, DDDL, and how it would interwork with the SDF. So this was our third meeting with the Azure DDDL team. We discussed in the meeting that was actually yesterday on Monday about the enhancements that would take for SDF and DDDL, that we can improve both of their expressiveness and also how they can work together. So for example, how could we talk about external ontologies using SDF and DDDL, but in a way it would be easy to translate that information from one model to another. So then we can use SDF as a glue between different ecosystems going from one to DDDL ecosystem. Also, one of our favorite classic recurring topic is the units. So when you measure something, often you want to tell what is the unit for an additional semantic information. And that's a topic that is on the surface very simple, but when you look in a bit deeper, it turns out to be quite complex. And here in particular, in SDF, we've been aligning with the CNML units with additional feature coming in that we can refer to external ontologies for additional units. But then in DDDL, there are some units that are not in CNML units and are not quite suitable for the CNML unit registry. How do we deal with those, for example? We also did discuss about some late tooling improvements. So we've been working on tools in the SDF work to convert models between different ecosystems. So we have implemented a toolset for go between SDF and DDDL. So here we discussed the latest advancements on that, and also what we've been doing. We did convert all the existing SDF playground models, so a set of models coming from the OMA, Laivotanto IPSO ecosystem, OCF ecosystem, and a few from ZigBee ecosystem into DDDL, and be able to then use those with the Azure Digital Twin tools. And then also another exercise we have done is we took a set of DDDL models that are describing a domain-specific system and converted those into SDF. There are few things missing in the translation, in particular licensing information that has turned out to be very, very useful information to carry in the models. So we might be seeing that kind of improvements coming to the DDDL later on. And overall, a big topic here is the sharing, converting, and publishing the models, so that we can all learn from the different ecosystems and work on ways to improve compatibility across different ecosystems. One particular plan for the way forward that we discussed in the meeting on Monday was this grand challenge hacking plan. So how could we use, for example, SDF described devices? Say you have an Laivotanto device that is using IPSO models that we have described SDF, how you could use SDF as the tool in between to go get those devices connected to your Azure Digital Twin system. So you, for example, convert those IPSO models into DDDL models, import them to a system, and have that way more easily your IoT system up and running. So we have now early plans on getting that kind of hacking activity ongoing together with the DDDL team. So that was a quick overview on the Wishy activities. Any questions or comments here? Okay, hearing none, but you're of course all welcome to join the future Wishy meetings. We do have a plan to have the next meeting, hopefully before Thanksgiving, but we'll be able to still come back to these topics. And also another topic that we're planning to look at closer is the Web of Things thing description that we didn't have a chance to talk in our previous Wishy call. That's going to be on the future topics. But we will be announcing when the future Wishy calls, as usual, on the Thing to Think Research Group mailing list. Okay, then we have next the W3C Web of Things update and Michael McCool. Michael, would you like to share your screen?
I will attempt to do so.
No, it should be showing up in a moment.
Hold on a second. Hold on, I have to let it allow it. Hold on. I have to restart Chrome.
Okay. Oh. Okay. While we wait for Mike McCool to come back, Michael Koster, do you want to check that your screen sharing works, or alternatively, we could share the slides?
You can the slides, because I only really have 2 slides. My update will be brief, and I think that it makes sense. I can just do it.
Okay, now I actually see Michael McCool is back.
We can also share the PDF if that helps.
Okay, now let's see. And by the way, Michael, you don't seem to have audio right now.
You should hear me now and see my screen.
Now we can hear you and see your screen. Thanks.
Sorry about that. Recent OS upgrade apparently reverted all my permissions. Okay. Anyways, I have 10 minutes. Let me talk about the W3C Web of Things, which I should be on this slide. And I actually have, now I have to fix what I was doing. Right, so I have 2 things in this deck. One is a what is what, and one is recent activity. Because of limited time, I'm only going to do very quickly do what is what, assuming most people have seen it. And I'm going to spend most of my time talking about recent activity. I will say that I have more slides than I will have time to spend on. So you can go and find out more information on the slides we uploaded, including hyperlinks to various things. Okay, what is what? Basically, we're part of W3C. W3C does web standards, and what we're trying to do is extend and adapt web standards to apply to IoT. Now, we're in our 2nd charter. We've already published 1 spec, which is the thing description, which is metadata describing IoT devices and their network APIs. And the basic idea is to describe interfaces rather than prescribing them. And so you basically get this JSON LD file. It describes how to talk to a device and also creates an abstraction so you can deal with the device at a high level abstraction in terms of properties, events, and actions, as opposed to the details of the protocols to implement that. It also includes data schemas, so you know how to format and unpack information going to and from the device. It also supports multiple protocols, so you can describe HTTP or CoAP or MQTT. I won't go into detail about this too much. I just want to mention, some links here. So we have, several. We've already published TD 1.0. We're now working on TD 1.1. I will say the deadline is basically the end of this year for feature freeze. So we're now in cleanup and finalization phases for these. There's also a new spec for discovery, which is how to find and get thing descriptions for devices, which I think is quite important for overall usability. And this is actually overlaps or impinges upon some IETF topics I'll mention in a minute. And profiles, which sort of limits the scope for certain interoperability scripts. And you also go to our website. Remember one thing, the website is useful to find out recent status. All right, so that was all I wanted to spend on what is what. And now I want to talk about what we've been doing lately. So we just finished a plug fest. We had a whole bunch of projects. I won't have time to go into them, but I will mention that one of them was converting STF to thing models. Thing models are kind of like templates for TDs, and they sort of fill the same function as STF and DTDL, and we're looking at interoperability between them. TDs themselves are designed to describe instances of devices, particular devices. And so they have concrete URLs and IDs in them. TMs are classes of devices. There are several other things, including geolocation, NHK integration, and things like this. We also recently had some presentations about some couple new commercial applications. So Takanaka Corporate Construction Company out of Japan has actually built a very complete system using WAT for building information models. So this is in the application domain of smart buildings, and building information systems often include lots of devices from different vendors with different standards. So it's a good application for WAT, which is designed to clean that up and to also track metadata about devices. There's also a startup, which is a spin-off from Technical University of Munich, which has been very active in WAT, and they are basically building an IoT dashboard based on using thing descriptions to describe devices from different vendors. As part of our discovery implementation, so W3C requires at least 2 implementations of every feature before something becomes a standard. So because discovery is new, we have to worry about implementations. And there's actually 2 parts to the discovery. There's first contact protocols, which leverage existing discovery mechanisms like DNSSD. And there's a directory service, which allows you to search and query metadata. I will say that that query service also includes XPath and Sparkle and JSON Path. At any rate, we need 2 implementations of directory services. We have 3. And so we have one out of University of Barcelona, UPM, WAT Hive. We have one out of Fraunhofer, and we have now one out of Logilab, which is based in, which is associated with Siemens. The Logilab one supports Sparkle, and Sparkle, of course, can be used for semantic queries and very powerful searches. Regarding touch points with IETF, we wanted to include JSON path queries in our directory service. Unfortunately, one challenge there is not a standard, but there is a RFC draft in IETF. But because we have to freeze our features by the end of the year, we basically are scratching our heads right now with what to do. I think the plan is we're going to make JSON path a informative experimental feature, and we're going to have to we want to have at least one mandatory query mechanism for directories. That was going to be JSON path. If it's not a standard, we can't do that. We don't want to mandate implementation of XPath or Sparkle, both which are quite complicated. So we're basically looking at doing a minimum query implementation for now and transitioning to XPath as soon as we can with a 1.1 spec in the near future. So we're kind of waiting for JSON path to get nailed to the wall so we can depend on it. Other relationships are Core RD, which is obviously also a directory service, but we're using it as a first contact mechanism, as an on-ramp into our directory, which supports more advanced features like Sparkle. We're also going to be having a discussion on October 28th about other touch points, such as signatures and signing of JSON payloads and so forth, and SQL payloads. And of course, ASDF, we've been exploring the feature completeness of conversion between TMs and SDF models. There's a couple other things that are under discussion. These will not be normative deliverables, but are things that are being discussed in the interest group, which looks at experimental ideas. So one thing we're looking at is ontologies for geospatial data. And this needs to be coordinated with organizations like the Open Geospatial Consortium, the Spatial Data on the Web working group inside W3C, OpenAR, and a bunch of other groups that depend on geospatial data. This type of data is especially important for smart city applications, and it's used both for the location of IoT devices and for dynamic location of devices. And so one of the challenges is how to deal with the fact that sometimes this data is static and sometimes it's dynamic. There's also different requirements around AR versus like mapping regarding, and also differences between the location of the device and the location of the feature of interest being measured, which might in some cases be different. There's also quite a lot of variety about what is geospatial data. It's not just location. It could be orientation. It could be velocity. It could be heading. Different coordinate systems. So it's quite a complicated thing. The other thing we're looking at are signatures. So we wanted to sign TDs, but TDs are quite large and they need to be modified, and we need to support chaining or other features. So the existing signature mechanisms for JSON weren't quite powerful enough. And we've been looking, and we're going to have a discussion on per 28 about, how can we adapt or extend what's currently out there? Is there any way we can use current standards, or do we need something new? So we've got that draft proposal for a new thing, but I really like to figure out if I can use existing standards instead. There's also a JSON LD signature spec in the pipe, but it's based on RDF. You have to expand it into RDF and canonicalize the RDF, which requires RDF processing, which we're trying to avoid. Because just verifying the signature really shouldn't require pulling things into an RDF database. So there's a bunch of practical concerns there. And finally, we're in the midst of defining our new charter. We're going to be extending our current charter for 6 months. So our next charter would start next July. And we had to defer a bunch of features for compatibility reasons to TD 2.0. And we're also probably going to look at maybe making normative some of the stuff that I mentioned above, like geospatial ontologies. The other thing we're looking at seriously is managing data itself. So right now we have a directory for metadata, but what we really want maybe is a directory for data. And there's actually some IEEE activity around that as well for doing queries over intervals that we need to align with. Anyway, that's a brain dump, but if you have any questions, I don't know if we have time, but I'm open to them.
Thank you, Michael, for the overview. And of course, we'll be having follow-up meetings together where we can go in much more details here. Does anyone have any quick questions you want to ask right away? Please go ahead.
I have one quick question. You talked about JSON paths, and we're going to have a working group meeting in 2 weeks from now. Do we have any documentation that we could use for limiting a first version of the JSON path document to the features you actually need?
Yeah, so one question is whether there's a subset of JSON path that we know won't change, and we would implement just that subset. We need more examples in our directory document. There was a web page where the front end implementation had a bunch of examples. I think the key thing we have to support is keyword search and probably searches over the type, the at type of the document. And that's what we're looking at for the minimum functionality. And basically, you need to be able to find out, all the lights, for example, and then get their IDs. So we're currently discussing what is the minimum required functionality, and I think in 2 weeks' time, hopefully I'll have an answer to that that's more concrete.
Yeah, if we have one in 10 days, that might be even more useful.
Yeah. Well, we're in the middle of our face-to-face. I can bring it up we have 2 more meetings. Maybe I can bring it up tomorrow and try and get some feedback.
Just throw over something that is preliminary as soon as possible, because that will really help us streamline this.
Yeah, and I actually owe you a review of the JSON path spec and do a bit of a brain dump on what is the minimum feature requirement. But let me see if I can dig up as far as our other discussion. I do have an issue about this, and maybe I can just forward you the issue.
Great. Thank you.
Okay.
Great. Thank you, Michael. And yeah, looking forward to hear more about this. And then we have our final topic, Michael Koster and 1DM and an IoT schema update. And the slide should be showing up in a moment. And Michael, seems that you don't have yet audio stream.
You have to click your microphone.
I was stuck. I
Yes.
was stuck trying to share. You're gonna present the slides. I was stuck trying to share screen and I couldn't turn the audio on. Yeah, there you go. Yeah, so this is really what amount to our application semantic initiatives that we're tracking as one data model, and the earlier initiatives that we started, iotschema.org. So slide, please. Yeah, so one data model, just to recap, well, where we are. I don't really need to go back and talk about what we're trying to do because I think most of us know what it is and could just go look. So SDF is currently being developed in the ASDF working group. We've kind of successfully spawned that out a year ago. Our consensus process is developed and resolved in terms of what we're going to use. That Nicholas drove that very, very well, and some others, but Nicholas is our acting secretary for this process. So we're about to basically start reviewing models. We've already started the review and come up with what we're calling a provisional set of models for our first publication. That's really our status. And we picked sensors, and we picked some operational state and mode setting models. And I think we've decided we're going to broaden things beyond that, but that much has been decided. And the challenges we've encountered so far are about sort of, well, looking at, there are really a lot of different ways. Sensors are not really that easy. There are a lot of different ways that people design sensors and a lot of different layers of functionality and ways of reporting and features in the data model. And as Ari was alluding to earlier, different ways of handling units versus whether we have a sensor category for each unit or whether a unit is an attribute of a more generic sensor, things like that. So we're basically going to work through those and figure out what some reasonable solutions are for those. We've kind of decided to get something out the door, to demonstrate that we have useful stuff, but also we're not going to walk away from the harder problems. We're going to sort of step up and see if we can make some progress on maybe breaking things into modular features so that, and layered functionality so that we can describe simple sensors and complex sensors with the same set of basic building blocks. And that's sort of given rise to some discussions, as Ari also mentioned, on what we mean by class and instance and specializations of models, where you start with an abstract model and incrementally or successively specialize it. I don't really have a roadmap to present. We're not really working against a fixed time goal, but we do have this challenge of getting some provisional models published in our official vetted workspace area so that people can start using them and we can start rolling things out. So I can take questions on 1DM or just go through that. Why don't I just move on and try to talk about IoT schema because it's going to be fairly brief. Next slide, please. Yeah, so we started a long time ago, thought we were going to extend schema.org, but we built it according to the same event action property event meta model that that everyone seems to have in some one form or another, or a subset of. But ended up being that schema.org doesn't really want to go in the direction of having device definitions. That's just not really the kind of content they're scoped for. They want to keep things a little more generic and describe more like patterns. So, and our basic pattern stuff isn't really useful as it is without the devices to point to. So we're kind of not going to be extending schema.org right away, and that's really kind of the big news. What we're doing is working on realigning IoT schema with 1DM and other ontologies so that we can basically have the device and start looking at the problem of how we talk about devices in the context of the physical world. And so that kind of means like becoming sort of an RDF front end, maybe for other ontologies and integration, but maybe becoming more of an integration kind of thing where IoT schema would be a way that you could get RDF that that you could point to in a thing description. So we don't really have a clear idea. We're working on rechartering. I can't really see the last line of the slide. Is there? Oh, there we go. Yeah. So basically, what we're looking at though, and had some proposal from Siemens already, is some extensions in the meta model so that we can connect to physical relations, and we have another little ontology that we're looking at for that. So I don't know if I have a conclusion slide, or if that's really, I just wanted to sort of summarize where we're at on both of those activities. Is there any questions or comments? I have a couple of seconds, I guess. Otherwise, we're close to being back on time. Okay, cool. Thank you.
Yeah, I think that this is very interesting because we just had this discussion about relationships with respect to SDF and having a place where these relationships are already being discussed, and we might have something we can point to instead of reinventing the wheel. There is probably going to be very useful. So what's the best way for us to find out what's going on there?
I'm sorry, to find out what's going on where?
In that IoTschema.org activity.
Yeah, interesting. I have canceled the monthly meetings for a while, but basically we need to kind of restart that, I think, is what we need to do. So there's a mailing list that people are on, and I'll send out email, but that's a really good question. I don't really have a great answer right now, other than I will try to get things going again. We had the European vacation around August, September, and we didn't ever really start back up since that, but I think we have some more clear. One observation I will make, though, is that we're seeing people kind of knocking on the door at W3C around Web of Things, and sort of they have the whole problem. They have the, what's the common format? Where do my models go? How do I standardize the thing that I'm doing? So we kind of need to look at and maybe some kind of way of doing a little bit better integration across these things. And I don't know if IoT Schema, we already have a W3C community group, but it didn't ever really activate. And so we kind of, and W3C, well, Web of Things is in the middle of rechartering some things. So maybe it's time to look at that community group discussion, or maybe it's time to look at kind of opening up the venue. IoT Schema never really had a venue. We're just working off of, you know, Zoom and things like that, and Google Mail and what have you. Anyway, I don't want to like run us over time, but that's a good point, and let's make sure we sort of engage something and look at that, because I think there is a gap that needs to be addressed, and I think that we kind of have the right approach there, but the bigger integration is really the question. Yeah, cool.
Do you think IoT would be open to adding it to our deliverables, like a spec? through W3C and why?
That we need to look at some things where when people come to W3C, they have, you know, an answer for some of the other questions they have besides just what's the format.
Right. Interesting.
Okay, it seems to me that would be a good subject to have a discussion on soon with maybe a few other players from the IoT Schema side. So I think we should discuss how to set up such a meeting so we can get some progress on the physical relation types and other types of relations that we actually need in SDF as well in the long run.
Yeah, I think that's I totally agree, and maybe that's a good thing for Wishy also.
Great.
Okay, thank you. Thank you, Michaels. I think it was very good information and clearly, you know, a lot of good opportunities across these different activities and organizations to align our activities. So let's take a stab at that. And definitely, you know, in Wishy, we're more than happy to host this kind of discussions. So that could be a potential agenda item for our next Wishy meeting. Good. And now we're actually almost at the end of the meeting. We had already a good set of discussions here, and we did write a good big set of notes in the usual place. Please go check them out and see if we missed something essential or if we misrepresented your comments. It's always good to fix those before we publish the notes. But before we close for today, any final questions, comments from anyone? Okay, hearing none, so I guess our next meeting, well, we'll be all probably seeing in the upcoming IETF hackathons and IETF meetings, but the next more official Thinking Research Group activities are probably going to be then the upcoming Wishy meeting. So wishing you all well until then. Stay safe and looking forward to seeing you soon again. Thank you and bye-bye.
Thank you.